In this video, we're going to be talking about parallel and perpendicular lines, so let's begin. Starting off with parallel lines. Parallel lines are any two lines that will never intersect, and parallel lines have the same slope and different y-intercepts, right? So an example would be like this. We have this line right here, and this line right here, right? These two lines, if they continue and continue, infinitely continue, they will never intersect, right? Another example would be two straight lines beside each other, right? No matter how far you go, they're never going to intersect, right? And we can examine this and tell if two lines are parallel based on if they have the same slopes and different y-intercepts. So let's look at an example. In this example, we have y equals 3x minus 4 and negative 6x plus 2y equals 10, right? So what we're first going to do is we're going to find the slope and the intercepts of each line. So starting off with y equals 3x minus 4, we know that the slope is equal to 3, right? And the y-intercept is 0, negative 4, right? So if we graph it right here, we'll find 0, negative 4, which is right here, right? And the slope is 3, so slope is rise over run. So we're going to go up 3, and then 1 to the right, and then up 3, and 1 to the right, and we'll do one more, up 3, and 1 to the right. Right here. Now, for the other line, negative 6x plus 2y equals 10, let's put that into slope-intercept form, right? Y equals mx plus b. So we have negative 6 plus 2y equals 10, so I'm going to get the y by itself by adding 6x to each side. So we're going to get 2y equals 10 plus 6x, right? Because negative 6x plus 6x is just 0, so we can remove it from that side, right? Now I'm going to try and get rid of this 2 right here, and I'm going to divide each term by 2. So I'm going to get y equals 5 plus 3x, and just to rewrite that, we'll get y equals 3x plus 5, right? This would be the equation of the line. Now, we see that the two slopes are the same, right? We have 3 right here, and we have 3 right here, right? But notice that the y-intercepts are different. So we have negative 4 here, and we have 5 right here. So let me just write. So for this equation right here, the slope is equal to 3, and the y-intercept is 0 and 5, right? And we find the y-intercept by setting x to 0. So whatever the b value is right here, because this is the term b in y equals mx plus b, right? B is the y-intercept. Now let's graph this, right? We'll use green. The slope is 3 and the y-intercept is 5. So let's go to 5 right here, and let's go up 3 and 1 to the right, and then we'll go the opposite way. So right here, and we'll do one more right here. And notice that these lines will never touch. So if you continue this line all the way up here, and this line all the way here, and this green line all the way here, and all the way here, they will never touch. So this is an example of two parallel lines. Now, let's go over perpendicular lines. Now, perpendicular lines are any two lines that intersect at a 90-degree angle, right? And the slopes of these lines are a little different than parallel lines. So in order to tell if two lines are perpendicular, the slopes are going to be negative reciprocals of each other. And the product of the slopes of the two perpendicular lines is going to be equal to negative 1. So let's just clarify. A negative reciprocal is like this, right? So let's say we have the fraction 1 over 2. The negative reciprocal would be negative 2 over 1, right? So the denominator becomes the numerator and vice versa, and you do the opposite sign. So if it's a positive number, you're going to make it a negative number, and if it's a negative number, you're going to make it a positive number, right? And how two perpendicular lines look like would be like this. You have this line right here, and you have this line right here. As you see, it forms a 90-degree angle, right? So let's look at some examples. We have the two lines, 4x minus 14y equals 7 and 21x plus 6y equals 12. Now, to make it easier, what we're going to do is we're going to put each equation into y equals mx plus b, or slope-intercept form. So starting off with the first one right here, let's just bring it right here. We have 4x minus 14y equals 7. So what I'm going to do is I'm going to add 14y to each side, okay? So we're going to get 4x minus 14y plus 14y equals 7 plus 14y. Simplifying that, we're going to get 4x equals 7 plus 14y, right? And now I'm going to subtract 7 from each side. So we're going to get 4x minus 7 equals 7 plus 14y minus 7. Simplifying that, we're going to get 14y equals 4x minus 7, right? Now, what I'm going to do is I'm going to divide 14 from each term. So we're going to have y, right? 14 divided by 14 equals 4x over 14 minus 7 over 14. Bringing it up right here, we're going to get, we're going to simplify this. So we're going to get y equals, now if we have 4 and 14, we can divide each number or each value by 2 to simplify it. So we're going to get 2 over 7x, and 7 over 14 is 1 over 2. So the equation of this line is going to be y equals 2 over 7x minus 1 over 2. Right? Now I'm just going to erase this right here. Right? And this is the equation of the new line right here. So I'm just going to rewrite it up here. We have y equals 2 over 7x minus 1 over 2. I'm going to erase this. Okay, so this is the new equation, or the simplified or switched equation from standard form into y-intercept form. Now for the next one, we have 21x plus 6y equals 12. So what I'm going to do is I'm going to subtract 21x from each side. So we're going to get 21x plus 6y minus 21x equals 12 minus 21x, right? Simplifying this, we're going to get 6y equals 12 minus 21x. Now, what I'm going to do is I'm going to divide each side by 6. So we're going to get y equals 2 minus 21 over 6x, right? Now I'm just going to rearrange this to y equals negative 21 over 6x plus 2, right? And I'm going to simplify negative 21 over 6 into negative 7 over 2, right? Because we can divide each term, the numerator and the denominator, by 3. So 21 divided by 3 is 7, and 6 divided by 3 is 2. So we're going to get y equals negative 7 over 2x plus 2, right? This is going to be the equation of the new line. So I'm just going to erase this right here. And we're going to move it up here. So we have y equals negative 7 over 2x plus 2, right? And if we observe the slopes of these two lines, we're going to see 2 over 7x, or 2 over 7, right? And negative 7 over 2. and we're going to see that these are negative reciprocals. So we can tell it's perpendicular. But another way is to get the product of each. So if we multiply these two and we get -1, we know for sure it's perpendicular. So when multiplying it, right, these two cancel out. So that's just 1 and 1. And these two can cancel out, right? So that's 1, and this is -1. So when we multiply it, we're going to get -1. The product of these two slopes is -1, so we know for sure it's perpendicular. Now, let's graph these two. Starting with the first one right here, we have 2 over 7x minus 1 over 2. So the y-intercept is -1 over 2, so that's roughly here. And it's rise over run, so 2. So we go up 2, right? So 1, 2, and we go to the right 7. So 1, 2, 3, 4, 5, 6, 7. That's right here. And for the other one, the y-intercept is going to be 2. And the slope is -7 over 2. So we're going to find 2 right here, right? And we're going to go up 7 and to the left 2. So 1, 2, 3, 4, 5, 6, 7, 1, 2, right? And we're going to go the other way as well, so we get 3 points. So this way, we're going to go down 7 and right to the 2. So 1, 2, 3, 4, 5, 6, 7, 2. Right? And we're going to draw the line right here. And for this, we're going to draw the line right here. And we see that they do form a 90-degree angle right here. To make that a little more clear. And right here. So we can tell they are perpendicular. So that's the end of the video. We covered parallel and perpendicular lines and how to graph them and to see their point of intersection. If you guys have any questions, feel free to comment down below. Please like the video and subscribe, and thank you for watching.